3 minutes ago, the silence of the cosmos was broken. A new object, designated C/2025 V1 Borisov, was spotted drifting in the void between Earth and the path of our last interstellar visitor. It's bizarrely bright, yet almost completely tailless. A combination that seems to defy the known laws of cometary physics, and it's leaving experts completely stunned. Is this the start of a cosmic collision, a rare celestial alignment, or something else entirely? Let's delve into what we know. Discovery Night. How does a discovery that stuns the world begin? Not with a massive government array, but with one man and his homemade telescope. On the night of November 2, 2025, veteran comet hunter Gennady Borisov was at his private Margot observatory in Crimea. He spotted an unfamiliar blur moving against the stars. Borisov is no amateur, his name carries weight. In 2019 he became a legend for discovering 2I/Borisov, the first confirmed interstellar comet, a feat that cemented his place in astronomical history. Now, 6 years later, his sharp eyes and custom optics caught another cosmic outlier. He quickly calculated its position, its bizarrely bright magnitude of 12.1, and noted the critical detail: a sharp, distinct coma nearly half an arc-minute across, but absolutely no sign of a tail. This combination of features is profoundly strange. He immediately fired off the report to the Central Bureau for Astronomical Telegrams, the official clearinghouse for these discoveries. The entire astronomical world was about to be shaken awake by one man's relentless and solitary watch of the night sky. Global alert. When a single alert from a credible source goes out, how fast can the entire planet turn its collective eyes to the sky? In this case, the answer was just hours. As word of Borisov's discovery spread, observatories from Japan, Ukraine, Russia, and the Canary Islands raced to confirm the find. Digital images and brightness measurements flooded into official databases and online astronomy forums. The consensus was immediate and clear. Team after team reported the same bizarre features that Masayuki Iwamoto, another famed amateur comet hunter, would recognize: a condensed, brilliantly bright coma, but no discernible tail. Out of the first 10 independent observations, only 2 hinted at a faint, inconsistent tail-like structure, details that were quickly attributed to image processing artifacts. By November 3rd, the discovery was officially confirmed by the Minor Planet Center. The provisional tag was replaced with its formal name, C/2025 V1 Borisov. With that name came a call for urgent, continuous follow-up, turning one astronomer's sharp-eyed catch into a relentless, international campaign. This rapid, decentralized verification process is the hallmark of modern astronomy, a system that planetary scientist Sarah Seeger has championed as essential for tracking fast-moving celestial events. Rapid brightening. What if an object appeared out of nowhere and became 100 times brighter in just 5 days? That's the anomaly that turned C/2025 V1 from a curiosity into a global obsession. After the discovery, astronomers dug into archival data from automated sky surveys. They found the first traces of the object on survey frames from the Palomar Observatory, dated October 29, 2025. Back then, it was a barely there smudge at magnitude 17.5, visible only to the largest professional telescopes, but by the time Borisov spotted it, it had surged to magnitude 12.1. This 100-fold increase in brightness is almost unheard of, and sent a shockwave through the amateur astronomy community. This rapid surge, analyzed by comet light curve experts like Carl Battams, could suggest a sudden fragmentation event or the exposure of a massive fresh patch of subsurface ice to sunlight. It meant the object was now within reach of modest backyard telescopes, sparking a frenzy. Confirmation images poured in from Japan, Ukraine, and Russia, all showing the same tailless, condensed coma. The nightly exchange of data became a ritual, with observers worldwide confirming its stunning and completely unpredicted rise. 3 paths. Things are not always what they seem in the sky. An apparent close encounter can be a grand illusion, a trick of perspective covering tens of millions of kilometers. By the pre-dawn hours of November 7, 2025, the sky presented a fascinating but deceptive picture. C/2025 V1 Borisov, the interstellar comet 2B-I Borisov from 2019, and a third comet, C/2022 E3 ZTF, we're all tracing separate arcs through the inner solar system. From our vantage point on Earth, the new object and V1 Borisov appear clustered together in the constellation Virgo. But the reality, confirmed by orbital models from experts like Paul Chodas at NASA's Center for Near-Earth Object Studies, is a vast spatial gulf between them. On November 7th, C2025 V1 is the closest to us, at roughly half the distance between Earth and the Sun. Its path is bringing it upward from below our orbital plane. V1 Borisov, on the other hand, remains far out in the solar system on its hyperbolic escape route. They are nowhere near each other in three-dimensional space. The apparent alignment is a pure line-of-sight coincidence, a temporary illusion that exists only in our sky. It's a powerful reminder from orbital dynamicist Renu Malhotra's field of study that the cosmos has depth, and flat sky maps can be deceiving.
Dawn Watch.
Want to see this cosmic drama for yourself? Here's your guide for the early November dawn. The main stage is in the constellation Virgo, rising in the southeast about 2 hours before sunrise. This is where you'll find our two headline acts. The newcomer, C2025 V1 Borisov, is holding steady around magnitude 13. Anyone with an 8-inch telescope or larger under dark skies can spot its soft, round, tailless glow. Use averted vision, looking slightly to the side of the object, to make its faint light pop. Just a few degrees away is the brighter but equally mysterious III Atlas. It hovers around magnitude 10, also stubbornly tailless. For skywatchers like science communicator Bob King, this is a unique challenge, spotting two comets that break all the rules. But don't forget the third player. Over in the constellation Leo, you'll find C2025 K1 Atlas. It's fainter, but it's a favorite for photographers because it has a stunning golden yellow tail, a stark contrast to the other two. This fleeting alignment, from November 6th to 8th, is a rare opportunity to witness three completely different cometary behaviors in one morning.
Missing tails.
A comet without a tail is like a ship without a wake. It seems to violate the very physics of what a comet is, forcing us to ask a fundamental question: what is this thing actually made of? Both C2025 V1 Borisov and V1 Borisov before it have defied the textbook image of a dirty snowball. To understand why, we have to look at the physics of its dust, a specialty of astronomers like David Schleicher. The key factor is a value called the beta parameter, which measures how strongly sunlight and the solar wind can push on a dust grain. For small, lightweight particles, the push is strong, and they get blown back to form a classic sweeping tail. But for dust grains larger than a few microns, that force becomes too weak. These heavier, more refractory particles get lifted off the nucleus by sublimating gas, but sunlight can't push them away. Instead, they linger close to the nucleus, forming a dense, bright, and spherical coma, but failing to stretch out into a tail. This suggests a composition low in the fine-grained silicates common in our solar system's comets. This, combined with a high phase angle that amplifies forward scattering of light, creates the bright, tailless apparition we are currently witnessing, a true outlier in cometary science.
Brightness puzzle.
There's another mystery brewing, and it's centered on the interstellar visitor, III Atlas. This object isn't just tailless, its brightness is completely off the charts. Based on its distance and trajectory, standard models predicted it should be a faint magnitude, 11.2. However, real-time photometric measurements from early November place it at a stunning magnitude 9.8. That 1.4 magnitude gap means it is nearly 4 times brighter than it has any right to be. Planetary scientist Karen Meach, who specializes in these distant and often bizarre objects, notes this isn't from a sudden outburst. The coma remains stable and compact. So, what's going on? Scientists have scoured the orbital data for non-gravitational forces, the tiny rocket-like pushes from sublimating ice that can alter an orbit. So far, nothing significant has been found. The leading theory points to its composition, a possible mix of less volatile materials that are creating an unusually dense, highly reflective coma. For now, III Atlas's anomalous brightness is one of the most intriguing puzzles in the sky.
Waiting for images.
We have thousands of dedicated eyes on the ground, but the definitive answers to the biggest questions are waiting in orbit. So, why aren't our most powerful space telescopes looking yet? In early November, China's Tianwen Mars probe released a short, low-resolution video clip of C-2025 V1 Borisov. It confirmed a bright coma, but honestly, it offered no new details, leaving key questions unanswered. The delay in its release really highlights the challenge of getting timely data from major space agencies. All eyes then turned to NASA's Mars Reconnaissance Orbiter, Hubble, and the James Webb Space Telescope. Calls for high-resolution images are growing louder, with multiple target of opportunity proposals submitted, but as of this week none have been scheduled. This isn't censorship, it's just the slow, grinding reality of mission priorities and technical planning. Planetary scientist Heidi Hammel, a veteran of securing observation time on these very telescopes, knows this process well. Pointing a billion-dollar observatory at a last-minute moving target requires immense coordination and displaces other long-planned projects. There's a bottleneck, and the answers we need about this object's true nature remain just out of reach, locked behind institutional review boards and the slow pace of space bureaucracy.
Solar storms.
Just to make things more interesting, the sun has been throwing a tantrum. A series of powerful solar storms have erupted, blasting the inner solar system with charged particles and intense radiation. Normally, this is great news for comet watchers. An event like this, a coronal mass ejection, should dramatically interact with a comet's coma. It typically lights up the ionized gas to form a distinct ion tail, often causing it to ripple or even disconnect entirely. Solar physicist Geraint Jones notes this provides a perfect natural experiment to probe the comet's makeup. Yet, both C-2025 V1 Borisov and 3I Atlas have completely ignored the solar rage. Observers have reported no major changes, no sudden tail formation, no outbursts, and no shifts in coma structure. Their lack of response is, frankly, bizarre. It suggests their comas are uniquely resilient, perhaps shielded by a localized magnetic field, or composed of materials that just don't react to the solar wind's plasma. As the storms continue, every astronomer is glued to their screen, watching for any sign of a delayed reaction from these two stubborn cosmic mysteries.
Testing predictions.
The internet is already buzzing with wild theories, ranging from a new class of natural object to something else entirely. But speculation is cheap. The only thing that matters is the data. Here are the clear, testable predictions to watch for. Some, like theoretical physicist Avi Loeb, would argue we must be open to extraordinary possibilities for interstellar objects, but even he insists on hard evidence. First, we would look for sudden changes in trajectory or any non-gravitational acceleration that cannot be explained by simple outgassing. Second, we'd watch for a fragmentation event that doesn't match known cometary physics, perhaps breaking into geometrically clean pieces. Third, any abrupt and unexplainable shifts in brightness or color that don't correlate with its distance from the sun. And fourth, perhaps the most telling, would be any coordinated changes or communication between this new object and the path of our previous interstellar visitors. As of right now, absolutely none of these have been observed. The current data, analyzed by teams including astronomer Ye Quanji, shows a stable orbit and a stable coma. Until that changes, the evidence points to a natural, if exceptionally strange, new visitor in our cosmic neighborhood. So here we stand, at the edge of a new cosmic puzzle. Two bizarre, bright, and tailless objects are crossing our skies, defying our models and challenging our understanding of the universe in real time. This isn't just about comets, it's about the fundamental processes that build solar systems, both ours and those countless light years away. As solar storms continue to lash them with no effect, and our best telescopes wait for a green light, the mystery only deepens. This story is a powerful reminder that discovery is no longer a rare event. It is a relentless nightly process, and the cosmos is far from done surprising us. What we learn in the next few days could change the textbooks forever, proving once again that the universe is always more strange and wonderful than we can imagine. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the cosmos. Until next time, keep looking up. Thanks for watching Stellar Tech.